All right, so let's solve a problem here. So we said the density of copper is, did you say 8.96? 8.96 grams per centimeter cube. And we know that this is going to be face-centered cubic crystallization. Tell me the radius of a copper atom. So how do we approach the problem? Okay, so I like that. If we can get the volume. So this is a cube, right? We know it's face-centered cubic. So we know that we're going to have this cube-shaped thing here. And we know that the volume of this thing is going to be equal to A cubed, which means that A is equal to the cube root of the volume. And A can be related to the radius, right? So if we can find the volume of the cube, then perhaps we can find the lattice cell parameter A. And if we know what type of cubic cell it is, maybe then we can relate it to the radius and get the radius from that, right? So let's do that. We know that the density of the cube is 8.96 grams. I'm sorry, we know the density of the bulk component is 8.96 grams per cubic centimeter. So how can I figure out the volume of the cube? Well, density is mass over volume. Do you agree with that? So how do we get volume? That's right. So volume is going to be equal to mass divided by density. All right, so we know density is mass over volume, so we know volume is mass over density, so the next step is going to be calculate the mass of the cell. How many atoms are in a face-centered cubic cell? 4. So we got 4 atoms in here. Now we just got to figure out the mass of an atom of copper. What is the mass of an atom of copper? Well, what's the mass of a mole of copper? 63.55 grams per mole, but I want it per atom, right? So there's 6.022 atoms in a mole. And then there's 4 atoms in the cell, right? So 4 atoms, 63.55 grams per mole, 6.022, that should say times 10 to the 23. And so you guys give me the mass of the cell. Yep, pretty close. 9.53. Yeah, I believe that. 1.53 times 10 to the minus what? And what's the unit on that? Grams. Okay, so now find the volume of the cell. That's right. So you're going to say 1.53 times 10 to the minus 20 grams divided by my density is 8.96 grams per, this should be grams per centimeter cube, not grams per centimeter. Cubic centimeters, right? All right, so that's the volume of this cube. So what is the length of the edge of the cube? Well, the length of the edge of the cube is the cube root of the volume, right? So what is that? A is equal to what? Cube root of 1.71 times 10 to the minus 7. 1.20 centimeters. Now we can relate that edge of the cube to the radius of the atom, which is what we did up here, right? There's our face-centered cubic. We know that they touch along the face. We did the math and calculated that the lattice cell parameter, the length of the edge of the cube, is 2 root 2 times the radius, right? So now we just plug this in and solve. So this is going to be 2 root 2 r is equal to 1.20 times 10 to the minus 7 centimeters. So r is just going to be that number divided by 2 root 2. And right now that's going to be some tiny number in centimeters. And we'll convert from there. 4.24, that seems big. Seems like we probably made a mistake somewhere in a calculation. This seems big. This is the right methodology, but this is telling me that it's 42 nanometers is the radius of an atom, or 424 angstroms. That's 100 times bigger than it's supposed to be. They should be closer to 400 picometers and not 400 nanometers or 400 angstroms. So something's off here a little bit. Let's do the 63.55 divided by 6.022 times 10 to the 23 again. I think that's going to be minus 22, not minus 20. Almost certain that's going to be 10 to the minus 22. That's because your 10 to the 23 is on the top instead of on the bottom. Yeah. Nick's like, I'll solve the damn. We have to calculate the mass of the cell, but the order of magnitude is not going to change by adding a 4, right? So we should say 63.55 times 4, right? That's 254.2. Divide that by 6.022, and that's 42.21. Do you guys agree with that? So this is, yeah, so this is going to be 42.2 times 10 to the negative 23, or 4.22 times 10 to the minus 22. So now that's drastically going to change these numbers as we go through. Right. Y'all get it sorted? All right, so now let's track this crap all the way back through and see what the actual answer is. So that's going to replace our mass here, which is going to change our volume answer here. All right, so take the cube root of that, and you'll get your length in centimeters. Okay. All right. So now we can divide 3.6 times 10 to the minus 8 by 2 root 2. 4.22 divided by 8.96 or 8.76 or whatever that density is. 0.47. So this should be 0.47 times 10 to the minus 23. Well, think about that. 4.22 divided by 8.76 or 8.96, that's roughly a half, right? And the times 23, 10 to the minus 3, 20, times 10 to the minus 23 is still there. So this could be 4.7 times 10 to the minus 24, right? And so now take the cube root of 0.47 times 10 to the minus 23. 0.47 times 10 to the minus 23. Take the cube root. All right, I just want to double check. 1.67 times 10 to the minus 8. 1.67 times 10 to the minus 8 centimeters, right? Now, that's the same as 1.67 times 10 to the minus 10 meters. Do you agree with that? Because centi is 10 to the minus 2, right? Great. So now we know the relationship here. 2 root 2 r is equal to a. And so what is r? All right. So the unit that we usually use here for radii are picometers, which is 10 to the minus 12 meters. That's right. So the radius here is going to be 59 picometers for this copper atom, or 119 for the diameter of the atom, right? So the radius is 59 picometers.